modern vehicles have an advanced form of EVAP, or evaporative system. This system recovers unburned fuel vapors and reintroduces it to the engine for combustion. The fuel tank pressure sensor is an integral part of the EVAP system. This sensor is positioned on top of the fuel tank, either mounted on a bracket or attached to the fuel tank itself. The sensor's job is to sense the internal pressure or vacuum of the fuel tank. On most EVAP systems, the purge valve applies vacuum, while the vent valve seals the fuel tank completely. Once this happens, the ECM or engine control module looks at the fuel tank pressure sensor. As soon as the sensor reaches a specific vacuum value, the purge valve stops applying vacuum, and the system stays hermetically sealed. Then, for the next few minutes, the ECM monitors the fuel tank pressure sensor for any drop in vacuum. If so, then logically, there is a leak at the fuel tank, seals, fuel cap, fuel vapor hoses, or any of the EVAP components. This is all done not to check for fuel leaks, but to detect small fuel vapor leaks that damage the environment. The fuel tank pressure sensor is a 3-wire device with a reference voltage, usually 5 volts, sensor ground, and a signal wire. There is one peculiarity about this sensor. On some manufacturers, like Toyota, the sensor stays at a mid-voltage point, with no vacuum or pressure. In case of Toyota, this is around 3.3 volts. This value is different per manufacturer. If vacuum is applied, then the voltage goes down, and vice versa. To test the fuel tank pressure sensor, first, using a multimeter, probe the value of the reference voltage. Keep sensor connected to wiring harness. 98% of all tank pressure sensors operate on 5-volt reference. Then, probe with the multimeter between sensor ground and battery voltage. You should see 12 volts, proving the sensor ground. Finally, jump the sensor's signal wire to the reference voltage and the ground. Probe at the ECM connector using your multimeter or a scan tool. You should see a value change between full minimum and maximum. If a problem is present, it'll be apparent very quickly. For the final part of this test, connect a small vacuum hose to the sensor port. Then probe at the signal voltage while applying a small vacuum with your mouth or a hand vacuum pump. You should see a changing value. This final step proves the mechanical aspects of the sensor, so as not to replace it unnecessarily.